Okay, so in this chapter, we're gonna talk about ionic compound and covalent compound. But before we go further into the chapter, let's talk about what a compound is. So compound, as we already learned from the previous chapter, are the combination of two or more atoms together. So when two or more atoms join together with some kind of interaction, they form a compound. And which kind of interaction is this one? We call this kind of interaction which atom use to join with each other, we call that types of interaction as bond. Right, so bond is a kind of interaction that atoms use to combine together to form a compound. And then we also call this kind of bond as a chemical bond. Right, so now the question is, why atom wants to join together? Why they cannot just stay alone in nature? What's the purpose of atom combining together to form a compound? So in nature, individual atoms are not stable, means they are unstable, and or you can say they have higher potential energy, so that's why they are unstable. So whenever they come together, they form a special interaction to form a compound and bring down their potential energy to a lower state. That means they become stable. So the purpose of atom to go from individual atoms to form a compound is to decrease the energy, decrease the potential energy, or you can say to get stability. So that's the purpose of making a compound. So there are two kinds of compound that we're going to talk about in this chapter. One of them is ionic compound, second one is covalent compound, and we're going to talk about each of them separately, which kind of chemical bond atoms normally use to form an ionic compound and what kind of chemical bond covalent compound normally use. Okay, so now let's get to the new slide. So bonding, like I already told you on the previous slide, that atoms normally combine through special kind of interaction that we normally call as a chemical bond. So bonding is the joining of two atoms in a stable arrangement that we already learned from the previous slide. And then how the elements or the atoms within the element normally combine together. There are three ways they can combine: by gaining of the electron, by losing of the electron, and by sharing of the electron. Right, and then we're going to talk about in which compound, either is covalent or a ionic compound, which kind of process element used to make a bond. So there are two different kind of bonding that we need to learn. One of them is ionic bond and second one is covalent bond. So the name is already telling you ionic chemical bond or ionic bond is present in ionic compound, and covalent bonds are normally present in covalent compound. So let's say how they are different. So ionic bond are result from the transfer of electron from one element to another element. So this is the important terminology that you need to know, that ionic bond always happen by transfer of electron. Means one element is donating the electron to another element, and that element is going to take the electron that is given by the first element. Then let's talk about the covalent bond. Covalent bond always formed by sharing of electrons. So this is the important term that you need to remember, is by sharing of electron. Means there is no transfer of electron between the atom. So whenever two atoms combine or come close together to form a bond, they always share an electron. Nobody is going to give the electron to each other. Now the question is, we have the electrons coming out in picture in this over here. Which kind of electrons atoms normally use to form this kind of bond, whether it's ionic or covalent? So the electron that we are learning in this particular definition are valence electrons. So remember this thing. So the electron that atom normally used to form any kind of bond, whether it's ionic, covalent, they use their valence electron. So this is one of the important thing. So now let's talk about our ionic compound first, and then we're gonna go on the covalent compound. So let's go to the next slide to talk about the ionic compound first. So ionic compound, like we already know, form through ionic bond. We have ionic bond in ionic compound, and they always form between two atoms. So one of the atoms should be a metal, and the second element, or you can say atom, should be coming from non-metal. So ionic compound is a combination of two elements or two atoms. One of them is metal and second one is non-metal. So if you see any compound that is a combination, has two elements, metal and non-metal, you can say that particular compound belongs to an ionic compound, right? And where you can find the metal, like we already talk about in the previous chapter, that metals are normally present on the left side of the periodic table, and then non-metals are on the right side of the periodic table. So if you know where you can find the metal, and then you can easily figure it out that particular element that we're going to talk about is whether it's a metal or a non-metal. But we're going to talk about more in the upcoming slides about this metal and non-metal. So ionic compounds, sometimes also called as a salt, and are composed of oppositely charged ions. So what is mean by we know what is mean by oppositely, but what is mean by that ions? So ions are the charge species. There are two kind of ion that we're gonna talk about. First one is a positive charge, second one is a negative charge. So you can say over here positive, second one we can say a negative. And we have a special terminology for positive and negative. If the charge is positive, then we call that particular charge as cation, and if the charge is negative, we can say that particular charge as anion, right? So if I say this element is a cation, so that means that element has a positive charge. If I say that, if you see any element has, we normally call that element as anion, that means that particular element has a negative charge, right? And the simplest ionic compound that you can see normally contain monoatomic ions. So what is mean by the monoatomic? Mono means single or one, atoms mean atom. So whenever you form an ionic compound, you always combine one atom with another single atom, right? Single atom. So one atom from the metal, one atom from the non-metal. So that's why you call as monoatomic ions, right? But we're going to talk about this again in the upcoming slide. So now let's talk about the ions. Like we already discussed about this terminology, ions. There are two kind of ion. One of them is cation, second one is anion, that we already talk about. But why element form this kind of anion? Why element form a positive charge or a negative charge? It's just because of the imbalance between the number of protons and the electrons in that particular atoms. Means if we already know what are number of protons, proton has a charge of +1, right? That we discussed in the previous chapter. Electron has a charge of -1. So for the neutral atom, if I talk about a neutral atom, so neutral atom always has the same number of positive charge as they have the number of negative charge, so they can cancel it out each other. But if any element has an unequal amount of proton and electron, that element always have some kind of net charge. And we're gonna talk about this thing in the upcoming slide, but right now just focus on this. If there is an imbalance between positive and a negative subatomic particle within an atom, you will always get some charge. For example, let's say if you have an element any random element A, it has 11 proton, and for example it has 10 electrons. So what should be the charge on this element A? What do you guys think? So the time I see, does it have a zero charge together? So we'll see. So this element has 11 proton, means 11 positive charge. I can say this thing, 11 positive. And then the time I see it has 10 electrons, I can say it has 10 negative charge, right? So if I add them both, 11 positive, 10 negative, what's the net charge on this element? +1, because you have one extra positive charge. They are not equal, right? Positive and negative. So that means this A element is a cation because it has positive charge, right? Same thing apply for the anion. If you would have the another element, let's say B, if it has 5 proton and 6 electron, what should be the charge on this random element B, any hypothetical element B? So the time I say is it has 5 proton, means it has 5 positive charge, 6 electron means 6 negative charge. So 5 positive, 6 negative. So if you add them both, you will get a net charge of -1, because negative is one more than the total amount of positive charge. So that means this element is an anion because it has a negative charge on the top of it, right? So this is the concept behind how you can tell which element is positive or which element has a negative charge, cation or anion. So another question is, why atom normally combine together? Like we already discussed, because they combine together to form a compound to get more stability. So how they normally get more stability? So there is a rule that we're gonna talk about right now, and then I'll explain you in the next slide. So the rule is called octet rules. So all the main group element is especially stable when it possesses an octet of electron in its outer shell. What is outer shell? Valence shell, the last energy level. So shell is we also call as energy level, right? So the last energy level we call as valence energy level, the last one. And then how many electron that valence or last energy level should have? At least 8 valence electron. If any element has 8 valence electron in the last energy level for the main group element, that means that element is stable. So let's go to the next slide and we'll talk about this octet rule one more time. So this is the periodic table, and then the name of the element is not given for all of them, but we know what are the main group element composed of this group 1A, 2A, 3, 4, 5, 6, 7 and 8. So these 8 groups we normally consist of main group element. And then if we know how many valence electrons you have in these particular groups that we already talked about on the previous chapter, group 1A, so group number normally tells you how many valence electron you have. So group 1A has 1 valence electron, group 2 has 2 valence electrons, group 3 has 3, group 4, 5, 6, 7, 8. So the last group has 8 valence electron in it, right? So if you remember the octet rule on the previous slide, I told you guys that any element in the main group element wants to have 8 electron in the last energy level called valence energy level, or how many valence electron you should have? 8 valence electron, right? So the 8th group element already has 8 valence electron or 8 electron in the last energy level. So that means any element in the group 8A doesn't wants to form any kind of compound because they are already stable. They have 8 electrons in there, so they don't want to interact with any other element because they're already is satisfied or stable, right? And what's the name of this group A element? Called noble gas element. So any element belongs to this 8th group in the noble gas group normally doesn't form any kind of compound with any other atom. They are stable alone, right? So now let's talk about the charges. If you can see the element in the group 1A, what's the name of the group 1A? Is alkali metal. Group 2A is alkaline earth metal. Group 7 halogens, right? So we're gonna talk about how whatever the charge you're seeing in each particular group for each element, how you're gonna get those charges. So group 1 always has a positive 1 charge, right? Group 2 always has a +2 charge. Group 3 always has +3 charge. For group 4 you might have a variable charge, sometime +4, sometime -4, +2, right, -2. So depending on, you have some variable charge. If you can see over here, the element belongs to the group 4. So group 5 normally has -3 charge. Group 6 -2. Group 7 -1. And group 8 has no charge, 0 charge, right? So let's talk about why they are getting the charges they have. So group 1 element has how many valence electron? How many electron in the last energy level for group 1A? 1, right? So how many electron this group 1A element wants to get into a 8 electron? 7, but there is no one who can donate the 7 electron to this group 1A element. So what's the best way? This group 1 element say, okay, I can donate the electron because nobody's gonna give me the 7 electron. So the time the group 1 element donate the electron, so what does it mean? Now that element has more number of proton compared to the electron because one of the electron is already gone. They already donated it. So that means they have an imbalance now between proton and electron, right? So what's the imbalance number? Just 1. So you have 1 extra positive charge. So that means group 1 element always has a +1 charges on those elements. Now let's talk about the group 2 element. How many valence electron in the group 2 element? 2 valence electron. How many electron it needs to make it into a 8 electron to fulfill the octet? According to the octet rule, they need 6 more electron. So that means nobody in the entire element is gonna give the 6 electron to these element in the group 2A. So what's the best approach? They say, okay, we can give it the 2 electron if somebody wants, and then we can get the stable electronic configuration, right? So they donate 2 electrons. So the time they donated 2 electrons, now they have 2 electron less in their atoms. So that means there is an imbalance of the charges. Now you have 2 more positive charges because the 2 electrons is already gone. So there is a charge imbalance. So that's why group 2 element always has +2 charges. Group 3, same thing, has 3 valence electron. They donate 3 electron because nobody is gonna give them 5 electron to make 8 electron in the last energy level. They form +3. Group 4, there is a chance they can form +4 or -5 because there is an equal chance of getting 4 electron or giving out the 4 electron. But for group 5A, how many valence electron this group 5A has? 5 valence electron. How many they need to make it 8? 3 more. So somebody is going to donate 3 electrons to the 5th group element to make that particular element last orbit or last energy level to a 8 electron. So that's why how many extra electron they are taking? 3 more. So that means you have a 3 more negative charge. So that's why you have a 3 negative charge in the 5th group element. Same thing apply for the 6th group element. You have 6 valence electron. how many more electron it need. Is better to take 2 rather than just give it out all 6. So that's why they have -2 charge, because they are taking 2 electron from somebody else, so they have 2 extra negative charge. Group 7 element has 7 valence electron. How many it need? Just 1 more electron to make it 8 to the last energy level. So that's why they have -1 charges, all the element in the noble gas family. And then what about the charge in the last group? How many valence electron it has? 8 valence electron, because it belongs to the 8th group, and they already have 8 valence electron. How much they need? Nothing. So that's why they don't donate, they don't take. So the net charge is 0. So this is how you normally remember what's the charge on each group in the periodic table, basically in the main group element, right? And then we have a spatial area in the periodic table. If you can see this area, we call this area as a transition metals, and they have a spatial characteristic. The metals in the transition elements normally show a different charges. You cannot say that if it belongs to this group it has that particular charge, if it belongs to this group it will have this particular charge. It might show a different charges sometime. For example, for chromium, chromium can form 2 different charges depending on which kind of compound they are making. Chromium can form +2, +3, so they are not fixed. Similarly, iron, Fe, they can also show +2, +3, so they are not fixed. So remember this, most of the element in transition elements normally show a variable charges. So this is the difference between the main group element and the transition element, right? Depending on which one has a fixed charge, which one has a variable charge. So now let's take an example of sodium chloride. We know sodium chloride is NaCl. How would I know this is an ionic compound? The time you see sodium belongs to the first group, so this is a metal. This is a metal. What about the chlorine, the second atom? It belongs to the 7th group, halogens family, so this is a non-metal. So this is how you normally predict the given element or compound are covalent or ionic. So this is metal plus non-metal, and what's the definition of ionic compound? Whenever metal and non-metal combine to form any kind of compound, they always form ionic compound. So let's take an example how they normally form NaCl. So this is your sodium atom, this is your chlorine atom. So you have 11 proton in there. How many electrons it should have? Because it doesn't have any positive and negative charge, it has to be equal. Positive and the negative has to be equal to get a neutral 0 charge. Chlorine, 17 protons, 17 electron, neutral charge. So how they're gonna make a compound? So chlorine has 7 valence electron in the last energy level, and how many it need more to make it 8? 1 extra. Sodium has 1 valence electron, so there is no one who can give it the 7 electron to the sodium, but it's easy for sodium to donate the 1 electron, right, to remove that extra electron that is present in the last energy level. So if you have chlorine, sodium say to chlorine, okay, I can give out the electron and you can take it, and then we can make together an ionic compound. So sodium donated the electron, and the chlorine is gonna take that electron that is given out by the sodium to form 2 kind of charges. Sodium will get positive charge because now it has 1 extra less electron, and chlorine will get a negative charge because right now chlorine has an extra electron, so that means extra negative charge compared to the positive. So sodium is gonna make a cation. I can say sodium is a cation and chlorine is your anion. So they form 2 kind of ion. So whenever you have a positive charge, negative charge, and we know this positive and negative charge, opposite charges attract each other. So whenever you have a two oppositely charged atoms side by side, they're gonna combine together and form a bond, ionic compound, right? So they're gonna form NaCl. In this case, Na is positive, Cl is negative, but they are neutral, so that's why we usually don't show our charges, right? The second important thing that you need to know, the net charge on the entire ionic compound is gonna be zero charge, net charge. So even though sodium is +1, chlorine is -1, when they combine, they're gonna neutralize each other, one positive, one negative. So the net charge on the entire molecule is right now 0. So remember this concept too. For ionic compound, the charge on the compound will be 0. Let's take one more example that we just learned on the previous slide. If you have calcium and if you have chlorine, how they're gonna make a compound? So they usually form a compound called calcium chloride, CaCl2. But how they're gonna form and which kind of compound they're gonna make, covalent or ionic? Ionic, because calcium is a metal, chlorine is your non-metal. So metal plus non-metal, ionic compound. But we'll see how they're gonna make CaCl2. So calcium belongs to the second group in the periodic table, and how many valence electron any element belongs to the second group has? 2 valence electron. And how many it need to make it 8? 6. So nobody's gonna give the 6. So the best possible way is calcium donate this 2 electrons, right? Now you have chlorine. Chlorine has how many valence electron? 7 valence electron. How many it need? Just 1 extra. If somebody's gonna give that 1 electron to the chlorine, then it's stable, right? Now chlorine will get stable. So but calcium can donate 2 electron. If chlorine goes to the calcium, it says, can you donate 1 electron to me? Calcium will say, okay, I can donate 1, but even though if I donate you, I won't get stable. I will still have 1 valence electron in my last energy level. So you have to bring your friend. So chlorine, you need 2 chlorine, second chlorine. So one of the electron will go to this chlorine, second electron will go to this chlorine. So now both of the chlorine has 1 electron. That means both of them get 8 electron in the last energy level. In the valence, how many valence electron now they're gonna get? 8. So now they are stable. So once calcium donated 2 electron, what's the charge on the calcium now? +2, because it donated 2 electron. Now they have less 2 electron compared to the positive charge. And then you have chlorine. Each chlorine will get -1. How many chlorine you have? 2 of them, right? So we usually write the formula as CaCl2. So this 2 is normally we call as a subscript, and it tells you how many atoms you have, how many atoms of that particular element. So for chlorine, how many atoms of chlorine we have for each calcium? 2. So that's why Cl2. And how many calcium we have? 1. We usually don't show 1, so that's why CaCl2. So this is how you normally form an ionic compound for any metal and non-metal together. So now let's talk about the properties of the ionic compound, how they are different from the element that they normally get formed from. So ionic compound have different physical and chemical property than the element from which they are normally derived or get formed. For example, if you can see in this picture, this is a sodium, this is a chlorine gas. So what's the property for the sodium? Sodium is a metal, right? Type group 1 element. So this is a metal, and this sodium is extremely flammable, whereas chlorine is a gas, right? But when sodium and chlorine combine together to form an ionic compound, they become a solid. If you can see over here, this is your NaCl. And what is NaCl? A common salt that we normally use in daily purposes, right? A salt. So this is how the ionic compound normally change their physical and chemical property from their individual element or atom that they normally get derived from. So now let's talk about a special compound called electrolyte. So before we talk about the electrolyte, let me ask you this thing. So let's say if you have an NaCl compound, which kind of bond you have in this NaCl is an ionic bond, right? We have right now an ionic bond. So this ionic bond is a strong bond. You normally don't break this bond. So how you gonna break this bond? When you dissolve NaCl in water, if you dissolve this thing, so now you're gonna break the bond because of the presence of water. Now the individual atom that you're gonna get is Na plus and Cl negative in the solution, because the charges get separated because of the presence of water. And because the charge gets separated, we have positive and negative charge present in the water, right? Like an ions. So electrolytes, now let's get to the electrolytes. So electrolytes are the ions that normally get dissolved in water and which can conduct electricity. So whenever you dissolve an ionic compound in water, you will always get a charged species separated from their original compound because of the presence of water. And because they are charged, they can easily conduct electricity. So if you pass electricity from a solution, from NaCl solution, a salt solution, that means you dissolve salt in water, electricity can pass through it. So salt solution is a good conductor of electricity because of the presence of electrolytes, the charge species or charge ion present in the water, right? So some of the most important monoatomic electrolytes include sodium from NaCl, potassium if we have KCl, another salt. If you dissolve this KCl in water, you will get K plus and Cl negative, the charge ion. So they can still conduct electricity. Calcium, chloride. So if you have any kind of charge species present in water, they can conduct electricity, and the solution we call as electrolyte solutions. So now let's talk about all the elements that belongs to the group 1, group 2 and group 3. Like we already discussed in the previous slides that the groups present in the group 1 form positive 1 charge group, elements belongs to the group 2 form plus 2 charge, and then so on. Group 5 form negative 3 charge, and so on, that we already discussed on the previous slide. So there is another way you can figure it out. What's the charge? So you can figure it out the charge on the cation by the group number they are present in. So any element, any metal, if you talk about especially this, normally true for metals. So any metal that is present in group 1, group 2 and group 3 in the main group elements, you can get the charge by the group number. So if you can see over here, group 1 is a metallic group, so that it belongs to the first group, plus 1 charge. Group 2 plus 2, group 3 plus 3, right? And then we already talk about why they want to combine with each other, like why metal in ionic compound, why metal form bind with non-metal, because to get stable they want 8 electron in the outermost energy level, right? So that they can become like noble gas element, because they are the stable in the periodic table, right? So every element in the periodic table wants to be like a noble gas element, right? That means to get stable. There's some exception, beryllium and boron, they usually form a compound or ionic compound that normally doesn't have 8 electron in the valence energy level and the last energy level. So these are some exception, right? Beside that, most of the element wants to be like noble gas element, like I already told you why. So let's take an example, right? How the element normally get stable. By donating the electron means by making a cation, or by accepting or taking the electron, or by making a anion. So let's take an example of sodium. So we have the electronic arrangement of sodium. Sodium with a +1 charge means sodium cation, and then neon, this is a noble gas, group 8 element. So now let's try to understand why group 1 element, in this case sodium, wants to donate 1 electron. Why not 2 electrons, right? And then you can apply the same concept with the rest of the metal. So sodium is a metal present in group 1. So how many valence electron sodium will have? 1. So let's see how many total number of electron this sodium has. Total electron 11, right? And then see how these electrons are arranged within the atom. So the first energy level will take 2, and then we already talk about Y energy 1 will take 2, Y energy level will second will take 8 electron. This is 2 electron. How many left? Just 1. So the last electron will go to the energy level 3. So this third energy level is we normally call as, for sodium, as valence energy level, or energy level. And then this electron we call as valence electron, right? Now let's go to the Na plus. So this is the electronic arrangement for Na plus over here. So now let's talk about the time you're seeing a positive charge, that means the valence electron, this is 1, is already being donated by the sodium. So which electron sodium donated? The last electron, the valence electron. So the time this electron is gone, now this level will became your valence energy level, the last energy level for sodium, because there is no energy level after that, because the electron that is occupying the energy level is gone. So there is no need for that energy level for sodium. So how many valence? Now these electron become a valence electron for sodium plus sodium cation. How many valence electron you have in the last energy level for sodium? 8. And this is same as for neon. Neon has 10 total number of electrons. So the 2 will go to the energy level 1, and the 8 will go to the energy level 2nd. And then we only know from the octet rule, so the last energy level for any atom has to have at least 8 electron to get an octet full, right? Octet rule. So this is a noble gas, it should have 8 electron, but if you compare these two electronic configuration between Na plus and neon, both has the same electronic arrangement. So that means now after donating 1 electron, sodium plus or sodium cation became a stable, like a neon, like a noble gas element. So this is why sodium can donate only 1, not more than 1. Okay, and then you can apply the same concept, right, for calcium, for magnesium, right, same thing. Now let's talk about the table. Now let's compare how many proton, electron, or the charge each these element had or has right now, that we discussed on the previous slide too. Sodium, sodium plus, and neon. So we have sodium, sodium plus, neon. Number of protons, sodium has an atomic number of 11, so that means number of proton 11. Sodium plus still 11. If you remember, I told you that you cannot change the number of proton, doesn't matter whether it has +1 charge, -1, +2, you cannot change the number of proton for any atom. Neon atomic number 10, that means number of proton 10. How many number of electron? Because sodium in this first one doesn't have any charge, so that means it's a neutral, so the number of positive charge has to be equal to the number of negative charge. So 11 11, so net charge is 0. Na plus, the time I see that is the positive charge, and how many positive? 1. So how many electron it donated? 1 electron. So that means now we have only 10 electron in that atom, and that's why, because you have 11 positive charge and only 10 electron, 1 electron is donated, that means you have a net charge of positive 1 because you have 11 positive. Then we have neon, 10 positive charge, it doesn't have any charge on it, so that means the positive has to be equal to the negative. So 10 plus 10 negative, net charge 0. So this is how. Let's take one more example. For, let's say, for calcium plus 2. So we have calcium plus 2. The time I see calcium, how many number of proton you have in here? 20, because it has an atomic number of 20. The time I see it has a positive 2 charge, that means let's assume if we wouldn't have this positive 2 charge, let's forget about this, what should be the number of electron? 20. But the time you see it has a plus 2 charge, that means 2 electron is already gone, and now it has 18 electrons, 18 negative charge. So what's the net charge? Plus 2. 20 plus 18 negative, so negative charge. So remember, whenever the element donate electron, they will always get a positive charge depending on how many electron they are donating. If they're donating 1 2 3, positive charge will be plus 1 plus 2 plus 3. And then if somebody is taking the electron, that will have a negative charge depending on how many extra electron they are taking from outside. If they're taking 1 2 3, negative 1 negative 2 negative 3. So this is how you can decide what's the net charge on that particular element. Okay, so we have one more example over here for magnesium plus 2 and neon again. So magnesium has an atomic number of 12, total number of electron 12, and then you have 2 electron in the first energy level, 8 electron in the second energy level, and 2 electron in the last energy level. So these 2 electrons we call as valence electron. And then the time C for, let's do for the magnesium plus 2, the time I see plus 2, that means 2 electron is already gone, because magnesium cannot donate more than 2, the time it's gone. Now this shell became a new last energy level shell, means valence shell, and how many electron it has? 8. So by donating 2 electron, magnesium became stable, because the last shell now had an fully filled octet, 8 electrons. And if you compare with the noble gas again with the neon, same electronic arrangement. So that means by donating 2 electron and get a positive 2 charge, magnesium normally get stable using a octet rule like a noble gas element. So now let's talk about the group 4 metal and transition metals, right? So group 4 metal is a main group element, but they normally show a variable charge because it has 4 valence electron, because this is 4a. How many valence electron the element in this group 4a? 4 valence electron. So it might take 4 electron from somebody else, or can donate 4 electron, or so because of this they might show different charges. The charges is not stable, or is not like constant. Similarly, for any element belongs to this transition metal group or area, they always show, most of the element normally show a variable charge, means different charges for the same element, right? And the time we say this is a metal, so they always form cation. Metal always donate electron. So just remember this thing, if you have a metal, they always donate electron. If you're talking about non-metal, they always take electron. So that's why metal always form cation, non-metal always form anion. Okay, so these two groups do not always lose all valence electron, so charge is less predictable. It can show different charges. If we lose a variable number of electrons to form more than one ionic charge, we normally use a Roman numeral. What is Roman numeral? 1, this is 2, this is 3, this is the Roman numbers 4, 5, 6, this is 6, this is 7, this is 8, then you have 9, then 10. So you need just 10 or 8 or 9 just to remember how to write the Roman numeral if you already didn't know that thing. Okay, so let's talk about one of the element, iron. This is your iron. What's the charge on iron in this particular element? +2. So we write iron, and then you have to specify in the parenthesis with a Roman character or Roman numeral 2. The same element in a different compound, when they combine with a different atom, the iron might show a +3 charge, not a +2. So that's why you have to show +3 or the Roman character 3. So remember this thing, you have to show the Roman letter or Roman numeral for any element that's normally show a variable charges. So that means if I had, let's say, sodium Na, you don't write sodium. What's the charge on sodium? 1, because it belongs to the first group, but you don't write Roman letter 1. Why? Because sodium always show a +1 charge, it doesn't vary. So you always show a Roman character with a variable charge element. There is some exception in the transition element. Even though this is silver, this is zinc, even though they belongs to the transition element that normally show variable charges, these two elements, even though they are present in transition element, doesn't show a variable charge. They always show +1 charge and +2 charge. So this is an exception for transition element, silver and zinc. So this is the same, this is a periodic representation of the same thing that we just discussed on the previous slide. These are the transition element, and if you can see, they always show a variable charges, same element, except zinc and silver. So these are the two common exceptions that we normally used for transition element. For group 4A, if you can see, they also show variable charges, Sn +2 tin, Sn +4 lead +2, Pb4 lead 4, right? So they might also show a variable charges. So you have to write the Roman numeral whenever you name any group 4 element with a variable charge or transition element. So now let's talk about group 5A, 6 and 7, and they belongs to a non-metal group. So that's why they always take an electron and form an ion, right? So non-metal always gain electron to fill the electron, the last energy level, to make it 8 electron. So depending on if any element belongs to the 5th group, it normally take 3 electron, so the charge will be -3. Any element belongs to the 6th group needs 2 electron to complete its last energy level to 8 electrons, so the charge will be -2. How many electron the 7th, the halogen family need to make it 8 electron in the last energy level? 1, so the charge will be -1, right? So we already talk about why they normally take these electrons to get the noble gas electronic arrangement, like a noble gas element, to fill it out the large energy level to a 8 electron. So let's take an example of one of the non-metal, in this case fluorine. This is a halogen family element. So fluorine has 9 valence electron, not valence, total number of electrons, total electrons 9. So let's talk, the first energy level will take 2, the second energy level will take 7 electron. So how many electron in the last energy level for fluorine? 7. How many it need to make it octet full? Mean 8 electron, it need 1 more. So that's why fluorine need F negative, always made a negative. So if you have to make the electronic arrangement for fluoride ion F negative, the first, how many electron it has right now? 8, 10 electron. Because of the -1 charge, that means it took 1 electron from somebody else. So now the first energy level is 2, second has complete octet 8, because of an extra electron this element got from somebody else. And if you compare with one of the noble gas element, neon, it has the same valence electron 8. So by taking 1 extra electron, fluorine becomes stable, and because it has 8 valence electron or octet, this octet is filled with 8 electrons, so fluoride ion becomes stable. So now let's compare the same thing again that we did for sodium. We have fluorine, fluoride, F negative ion, an ion you can say, or neon. Atomic number is 9, so proton is 9, number of proton is 9. For neon, number of proton is 10 because atomic number is 10. So now let's compare with the number of electron each has. Fluorine, no charge on it, so the number of electron negative charge has to be equal, so to become neutral charge. F negative one means it has 1 extra electron that it usually had, so that means you have 1 extra electron from 9 to 10, so negative charge of 1. Neon has the same number of electrons, 0. So this is how you can calculate the number of electron, proton and charge for non-metals. And we already talk about for groups 5, 6 and 7 anions, we already talk about what should be the charge on each of the group, right? So I'm not gonna go again on this, but this is the charges each group will have for to make an anion. So now let's try to do one problem. What ions are formed when cesium is your Cs, transfer electron to bromine is your Br. So if you see cesium belongs to group 1 element, alkali metals, the group 1. If cesium belongs to group 1, how many valence electron cesium has? 1. How many it can donate? 1, because this is a metal, so it can only donate cesium, right? So cesium, what should be the charge on cesium then? +1. Then bromine belongs to the 7th group, has 7 valence electron. How many more electron it need to make it 8? 1 extra. So somebody's gonna give 1 extra electron to bromine, so bromine after taking that electron is gonna make -1. So this kind of charges you can easily make if you know the arrangement or the placement of the element, which group that particular element belongs to. For example, if I ask you this thing, if you have magnesium and oxygen, what should be the charge? Which kind of ion these two elements normally make? So if you remember, magnesium belongs to the 2nd group, 2A, so that means it can donate 2 electron because this is a metal, it can only donate. Oxygen belongs to the 6th group, 6A, this belongs to the 2A. So if this oxygen belongs to 6A, how many electron it need? Because this is a non-metal, it need to have some electrons, so it belongs to 6. How many valence electrons? 6. How many it need more? 2 more, so -2 to make it 8. So this is how you normally make an ions for the ionic compound. Which one will make positive, which one will make a negative. Now let's do one more problem. Indicate the number of protons and electrons in the following ions. The time you say ions, it can be positive or negative. So let's try with the one iodine, negative. So if you go to the periodic table, you will see the number of proton for iodine is 53 because it has an atomic number of 53. So how many electron it should have? So if you have 53 proton, that means it has 53 positive charge, but the net charge is -1, so it took an extra electron, so that's why it has 1 extra electron, 54. Phosphorus, it has 15 proton because the atomic number is 15 in the periodic table, and the time you see a charge of -3, that means somebody donated -3 electron to the phosphorus, or phosphorus took 3 electron from somebody else. So that means it has 3 extra electron that it usually had. So that means 3 extra negative charge, 18. Lead, atomic number 82, number of protons 82. The time you see +2 charge, that means 2 electron is already been donated. So now it has 80 electron. 2 less than the positive one. So this is how you normally calculate positive and negative charge or number of proton or number of electron in that particular ion. Now we're going to learn about how we can form a formula for any ionic compound. How would I know which kind of formula these two elements or atoms normally form when they combine together to make an ionic compound? For example, NaCl. How would I know that NaCl is always NaCl, not NaCl2, NaCl3? So the time I see NaCl, this is ionic compound because metal plus non-metal, I know this is ionic compound. So what's the charge on sodium if this is an ionic compound? +1. Because sodium belongs to the group 1, the charge on any element that belongs to the group 1, it always has +1 charge. Chlorine, 7th group element. What's the charge on the 7th group? -1. So how would you normally combine or form a formula? You take a number, not the charge, only the number, and then just make the charge of the metal to the subscript of the non-metal and take the number on the charge on the non-metal and make it the subscript on the metal. So you just cross multiply the number, so you will get the number Na1Cl1, and then we usually don't write 1 so that's why the formula is NaCl. And you can cross verify what the rule says. For any ionic compound, neutral ionic compound, the net charge on the entire molecule has to be 0. So we know that sodium is a +1, chlorine is a -1, +1, -1, 0. So net charge on NaCl is 0. So that means this is a neutral ionic compound. Let's talk about the magnesium, Mg. Oh, why they form always MgO, not MgO2, MgO3, something like that. So now let's focus with the same concept that we did for NaCl. Magnesium belongs to which group in the periodic table? 2nd group, charge will be +2. Oxygen belongs to the 6th group in the periodic table, charge will be -2. So just take the number 2 and cross multiply, so you will get Mg2O2, and if this is 2 you will get a common ratio of MgO, right? So the formula will be MgO, or for this particular case, if you don't want to do this cross multiplication of the number, you can just add them together, because magnesium is -2 charge, oxygen is -2 charge. When they combine with a ratio of 1:1, the charge will be get neutralized, so the net charge is 0. We already discussed. So there are both ways you can solve this kind of formula for any ionic compound. Now let's try to do some more example on how to write the formula for any ionic compound. If I give you a form element sodium and then oxygen, which kind of formula these two elements can form together whenever sodium combined with oxygen? So before we make a formula, let's assume, or let's figure it out whether the combination of these two atoms will make an ionic compound or not, because let's figure it out. Sodium is a metal, oxygen is a non-metal, so metal plus non-metal, ionic compound. So we know this is ionic compound, and the time I know is ionic compound is a transfer of electrons from one element to a second element. So sodium belongs to the first group, it always form +1. Oxygen belongs to the 6th group, it always form -2 charge. So take this 2, take this 1, and then just cross multiply, put the subscript, make 2 to the subscript of Na, and then put 1 to the subscript of oxygen. So you will get Na2O, or you can write O1, but usually we don't write 1, so the formula will be Na2O. And how would you cross verify whether this ionic compound is a neutral one? So how many, this subscript, like I told you, tells you how many atoms you have. So you have 2 atoms of sodium, and each sodium atom has, what's the charge? +1. and you have two of them, so total charge is +2. Oxygen, how many atoms you have? Just one, and each oxygen hence was the charge -2, so they get neutral. So this Na2O is your formula for the ionic compound, because whenever you combine together you are neutralizing the charges coming from each other. Let's take one more example, aluminium and oxygen, which kind of compound or formula they can make. So again, they can form ionic compound. Aluminium is a metal, oxygen is a non-metal, they're gonna make ionic compound. So what's the charge on aluminium? Because this is a metal, belongs to the third group has a +3 charge. Oxygen belongs to 6th group, -2 charge. Now just take the number, not the charges, and then make the subscript, cross multiply. So Al will get this 2 from the oxygen charge, and oxygen will get 3 from the aluminium charge. So this is the formula that aluminium and oxygen is going to make when they combine together, aluminium oxide. And then let's verify whether this ionic compound is a neutral, no charge. So let's say how many atoms of aluminium you have? 2 atoms of aluminium, and each aluminium has, how was the charge? +3 charge. So +3 times 2 +6. Oxygen, how many atoms? 3 atoms of oxygen. How many charge on each atom of oxygen? -2. So -2 charge. How many atoms of oxygen you have in the compound? 3, -6. When you add them, this will become 0. So that means this formula is right, Al2O3. So this is how you can make an ionic compound between any metal and non-metal, if you know the charge on each metal and non-metal which you are going to combine. Now let's try to learn about how to name of any ionic compound. How would I name it? For example, NaCl. How would I know this NaCl is your sodium chloride? So we're gonna learn about how to name an ionic compound. So how you're gonna name it? First you have to figure out which element is making a cation and write the name of the cation. Name of cation. This has to be a first. And then if that cation is making a variable charge, or that element belongs to a transition metal that normally show a variable charge, you have to write name of the cation, and you have to do an extra work to write the Roman charge. You have to write the charge in Roman character that we just learned, 1, 2, 3. If that element or cation belongs to any of the main group element, you don't have to show the charges, because we already know what's the charge. So this is an important thing that you need to know. For example, let's say chromium. Chromium can show multiple charges depending on which compound they are making. So you have, whenever you write the name of the metal or a cation, you always show the charge. But if I write sodium, I just write sodium, no charge, because I know sodium belongs to the first group. It cannot show any other charge beside +1. So even though you don't write it in the Roman character, I know it's a +1. So remember the difference between where you need to write the charge and where you don't need to write the charges. Now the second part of the ionic compound is your anion, the non-metal. So whenever you write the name of the anion, always remember this thing, the ending of that anion part always end with IDE. For example, if it's a bromine, then bromide, the ending word is IDE. If it's fluorine, F-1, fluoride. Oxygen, because oxygen can always form -2, oxide. Phosphide, sulfide. So this is how you normally write any ionic compound. So let's take an example. Over here, one of the ionic compound is FeCl2. So the time I see Fe, and then if we see where the Fe's belong to in the periodic table, I know this is a transition metal. So transition metals show variable charges. So how would I know in this particular compound FeCl2 the charge on iron is +2? Because this Roman character telling me is a iron has a charge of +2. How would I know? So you can always calculate the charge. For transition metal, I'll show you how. So if you have FeCl2, do we know the charge on iron? No, I don't know, because it can show variable charges. But do we know the charge on chlorine? Yes, it belongs to the 7th group, and I know that any element belongs to the 7th group always form a -1 charge. How many chlorine is attached to this fluorine? 2 chlorine. Each chlorine show up -1 charge. How many chlorine you have altogether in this compound? 2. So what's the total charge coming from chlorine? -2. -1 from each of them. So to neutralize this -2, what's the charge should be on the iron? +2. That's why +2 negative to neutralize, because ionic compound has to be neutral. So that's how you normally know iron has a +2 charge in this compound, right? And then how you name it? You name the compound a metal first, and then show the charges if it's belong to the transition metal, or show variable charge. And then for chlorine you write chloride. The same principle over here on the right hand side, chloride. The ending word is id. The other important thing that you need to, whenever you're going to write the name for any ionic compound, you don't need to worry about how many atoms you have, for whether for cation or whether you're going to talk with anion. You don't write 2 chloride, 3 chloride, 5 chloride. You don't worry about the number of metal or non-metal. You just write the name of the metal and then the name of the non-metal that end with IDE. For example, calcium and Br2. The time I see calcium, I know it belongs to the 2nd group. It always has a constant charge of +2, right? So that's why I'm not writing, or we are not writing any Roman charges. So Ca is your calcium, name of the metal. Then bromine is bromide, so name is calcium bromide. So we are not writing 2 bromide, 3 bromide, just the name of the non-metal and metal only. So this is how you normally name it. For example, if I have a compound called Na2O, what should be the name of this Na2O? So sodium is a group 1 element or metal that doesn't show any variable charge, so just write the name of the metal in this compound, ionic, sodium, and then O is your oxygen. Instead of oxygen I write oxide. And if you can see, I didn't write 2 sodium oxide, 3 sodium, so we usually don't write anything. So the name is sodium oxide. Let's do one more, FeCl3. What should be the name? So the time I see again Fe, I don't know what's the charge. Can be +2, +3, but how would I know which charge you have on iron on this? So the time I see chlorine, each chlorine is -1. How many chlorine you have in this compound? 3. So what should be the negative total charges on chlorine? -3 charges. So iron has to show +3 charge to neutralize this thing. So I can write the name iron 1, 2, 3, and then chlorine is your chloride. So this is how you normally write the name of any ionic compound. So this is a table that will help you to understand more about the naming of ionic compound, but we already talk about all the type of question that we might ask you or that you need to know. For example, this calcium bromide, you should know why this is calcium bromide, not calcium parenthesis 2 bromide. PbCl2, the time I see Pb, I know it can show variable charge, that's why Pb is your lead. You have to show the charge too. How would I know this lead has a +2 charge? Because chlorine is -1. How many chlorine you have? 2 of them, so +2, lead 2 chloride. So we already talk about this thing, but make sure you read it, this table, and then try to understand the same concept again. So now let's try to do one problem on this concept that we just learned. So the problem saying write the formula of unit for sodium sulfide. How would I know what's the formula for sodium sulfide? I know sodium is what? Na. Sulfide is your sulfur. right? So I can say sodium sulfur, but how would I know this is N2S? So remember, sodium has a +1 charge, sulfur has a -2 charge because it belongs to the 6th group. So take the number, cross multiply, you will get Na2S1, or you can say just Na2S. So this is how you normally form a compound from the name. Magnesium nitride. Magnesium is what? Mg. Nitride is nitrogen. Magnesium has +2 charge. Nitrogen has -3. Take 3, put it with magnesium. Take 2, put with nitrogen. So Mg3 and 2. Copper 1 chloride. The time I see copper, I know copper is Cu. And the time I see 1, I know the charge on copper is 1. Chlorine is just 1. What should be the charge on chlorine? 1. So the formula will be CuCl 1. Then you have copper 2 chloride. The time I see copper, and then the time I see 2, I know this is +2. Chlorine -1. Cross multiply CuCl2, because Cu has just 1. We usually don't write 1, so CuCl2 will be your answer. So this is how you normally solve any problem on naming. So let's do another problem. Write the name of the following compound. Na2O. How would you know? This is all our ionic compound. I know Na is a group 1 element, sodium oxide. Mg is magnesium. I is iodine, so iodide, magnesium iodide. KCl is potassium chloride, and then ZNO is zinc oxide, right? So this is how you name it. Name of the metal plus name of the non-metal plus IDE, oxide, iodide, chloride. Now we have another topic called polyatomic ions. So the name is already telling you what this kind of ion is. Poly means many, atomic means atoms. When more than one atom combine together to through like some kind of one or more kind of covalent bonds, they form polyatomic ion. They always form from molecules, and they always contain an unequal number of proton and neutron. That's why they always have some kind of ions. It can be positive, it can be negative, right? Cation or anion. For example, NH4 plus. This is a polyatomic ion because it has more than one atom. And then why this is ion? Because of the positive charge, and we call that as ammonium ion. CO3 -2 is also a polyatomic ion, named as carbonate ion because it has a -2 charge. So always remember this thing. In polyatomic ion, the charges given on the top belongs to the entire molecule. So this -2 charge is not belong just only with the oxygen, but it belongs to the carbonate CO3. Similarly, this +1 on ammonium belongs to the entire NH4, not just only on hydrogen. So keep this in mind. So this is a table that contains all the polyatomic ion that you need to know about for this class. So there are some common polyatomic ions. One of them is acetate, CH3CO negative. So this negative charge belongs to the entire compound molecule. Carbonate, like I already told you, CO3, this -2 belongs to entire one. And then same thing for all the polyatomic ion. So we have different hydroxide, OH negative, sulfate, SO4 2 negative, sulfite, SO3 2 negative. So make sure you know about these polyatomic ion and this polyatomic ion are basically anion. So I can say polyatomic anion, negative charge. If you can see, each and every polyatomic ion has a negative charge, so that's why this is an anion. And this table shows you some polyatomic ions that has a positive charge called cations. So one of them is ammonium, NH4 plus, hydronium, H3O plus. So if you see this kind of polyatomic ion in a compound, we know that this polyatomic ion always form a positive cation, a positive ion. So now let's try to learn how we can make a formula for any ionic compound that include a polyatomic ion. For example, Let's say, how would I know this magnesium hydroxide always form MgOH2? So let's try to make the formula. If you have magnesium and OH, the time I write OH, if you remember from the table for the anion, OH is your hydroxide ion. So what is your hydroxide ion? Is -1 or just negative. And magnesium is a metal, belongs to the second group, +2. Now it becomes this common ionic compound again. So +2 will go with the OH, 1 from the OH goes with the magnesium. So the formula will be Mg, then you have OH, and then make sure you have to write a parenthesis and then write 2, because the 2 that is coming from magnesium into the subscript of OH, hydroxide ion, this 2 belongs to both O and H simultaneously. If you write something like this, OH 2, then it's wrong, because it's saying you have 2 hydrogen atom and 1 oxygen atom. So make sure you always show a parenthesis and then write the subscript. If I say aluminum hydroxide, Al, then you have hydroxide, aluminum has 3, then the formula will become, just cross multiply Al1 and then OH parenthesis 3, aluminum hydroxide. So this is how you normally make a formula for any ionic compound that contain a polyatomic ion. For example, one more, if you have ammonium is a +1 charge, it's a cation polyatomic ion, and then chlorine -1. So the formula will be NH4Cl, called as ammonium chloride. Right? So this is how you normally form any ionic compound or formula from polyatomic ion, whether the polyatomic ion can be negative charge, anion can be positive charge. So all this example on the top, anions are negative, and the last problem, and polyatomic ions are positive or is positive. So let's try to name ionic compound that contain a polyatomic ion. Right, so you always write the name of the cation or the name of the anion. You don't write IDE like you usually do for normal monoatomic ionic compound. Your name should not be end with ID. You have to just write the name of the cation and directly name of the cation, whatever the name for polyatomic ion, because polyatomic ion can be positive, can be negative. So you have to just name it, don't end with ID. For example, Na2CO3, Na is your sodium and CO3 will be your carbonate, and this is the same name for polyatomic anion, because carbonate is what, CO3 -2. So we are not writing the name or ending the name with IDE, so it's sodium carbonate. For example, NH4Cl, let's do it one more time. If you write NH4Cl, what is NH4Cl? NH4 we know is an ammonium, so I can write ammonium and then Cl is chloride. So now the question is, why I am writing IDE for chlorine? Because chlorine is not a polyatomic ion. So this rule work only for the polyatomic ion. If that the other compound is a monoatomic ion, chlorine is a single atom, then you have to end the name with IDE, chloride, right? But in this case, CO3, sodium carbonate, even though this is also an ion, but this is a polyatomic ion, so that's why we didn't write IDE. So remember this concept. Let's do one problem on the naming of ionic compound containing polyatomic ion. So NaOH. So Na is your metal and OH is your polyatomic ion. What is OH? Hydroxide. So sodium hydroxide. AgNO3. The time I see Ag, this is your silver. And silver, I'm not writing anything in the parenthesis because it always show +1 charge. This is the one exception, right? So silver, and then what is NO3? NO3 is your nitrate ion. This is a polyatomic ion. So nitrate only, not nitride, right? Whenever you have polyatomic ion, you always name the same name for the polyatomic ion. Then you have NH4 2CO3. Then in this particular compound, both of them are polyatomic ion. One of them is positive, one of them is negative. So you have to just write the name of the polyatomic ion. NH4 is your ammonium, CO3 is your carbonate. So ammonium carbonate, that's it. So this is how you name ionic compound containing polyatomic ion. So now let's try to do one more problem on this. Write the formula unit for lithium hydroxide. The time I see lithium is Li, and then hydroxide is OH negative 1, right? And then lithium belongs to the first group, then it has +1, OH is -1, so you will get LiOH, lithium hydroxide. Then you have aluminum carbonate. Aluminum is Al, carbonate is CO3 -2. This is polyatomic ion. Charge on aluminum is +3 because it belongs to the third group. If you cross multiply the number, you're gonna get Al2 because this 2 is gonna go into the subscript of Al. Then you have to write CO3, and then you have to put the parenthesis because the number that is coming from aluminum charge is gonna go outside the parenthesis, because this 3 belongs to the every atom that belongs to carbonate CO3. So the formula will be Al2 CO3 parenthesis 3. Then you have acetate. Sodium is your Na, and then acetate is your CH3 COO negative. So the charge on sodium is +1, acetate, the entire acetate is -1. So when they combine together, they're gonna form Na CH3 COO sodium acetate, because the charge is going to balance. So this is how you normally form a compound, or you can write the same compound like this, CH3 COO Na, right? So this is how you normally form a formula for any ionic compound containing polyatomic ion. So now we are done with the ionic compound. Let's talk about a second type of compound formed by the atoms when they combine together, called a covalent compounds. So covalent compound are formed by atoms or elements where both are non-metals, or you can say non-metal should combine with second non-metal. Whenever you have this condition, that means you are making a covalent compound, right? And which kind of bond you will have? Covalent bond. And what is covalent bond? Covalent bonds are normally formed by sharing of electrons. Sharing of electrons means there is no transfer of electrons. So both the atoms or elements say, okay, I cannot transfer the electrons to you, or I cannot take the electrons from you, but we can both share the electron, like a 50-50, right? For example, if you have hydrogen, how many valence electron you have for hydrogen? 1 electron. And second hydrogen has 1 electron. And for hydrogen, this is an exception. Hydrogen doesn't need 8 electron in its last orbit. It needs just 2 electron. If the hydrogen has 2 electron in the last orbit, that means hydrogen is stable. So make sure hydrogen and helium. These two elements need just 2 electrons in the last orbit, except that most of the element need 8 electrons. So let's say hydrogen with 1 electron goes with the second hydrogen. If they want to make a compound, what they're gonna say, okay, I cannot give 2 and 1 electron to you, or you cannot give the electron to me to make it 2 electrons. So what we can do, let's share. Let's make a bond where you are sharing 1 electron, I am sharing another electron. So now this is a partnership. So this electron, this hydrogen, first hydrogen has 2 electron, 1 and 2, because this is a partnership, and the second electron also has the second 2 electron. So they are in partnership. So now 2 electron belongs to both the atom. So now they are stable. So this is how the covalent compound share the electron. We're gonna do more example, but this is just a concept. So now let's talk about the diatomic elements. Certain element in the periodic table normally exist as a diatomic element, means they combine with another atom from the same element. For example, H2, hydrogen gas, nitrogen gas, oxygen, fluorine, chlorine gas, bromine, iodine. So if you see fluorine, they usually form diatomic, chlorine diatomic. So these 4 belongs to the halogen family, halogen group or halogen family. So we can say element in the halogen group or halogen family normally form a diatomic element, right? But you have to just remember this thing. Now covalent compound normally formed by sharing of electron, and that sharing of electron form a bond called covalent bond. So covalent bond is nothing, is the sharing of electron, a chemical bond where you normally share the electron, right? So valence electron are being shared because valence electron are the electron that is normally take part during a chemical reaction, whether you have to make a bond or break a bond, right? So like we already done this example, hydrogen atom have partially filled first orbit. How many electron? Hydrogen has just 1, right? And a hydrogen atom has to have 2. That's why they make a bond. The same example that we did, electron, electron. Now both of them has 2 electrons. So this is how, and this one is a sharing of electrons. So this is a pictorial representation of whatever thing that we understood already for hydrogen. So this is 1 proton for hydrogen, first proton for the second atom, 1 electron, valence electron, 1 valence electron. When they're gonna combine together, they're gonna form this S2, hydrogen, and 2 electron shared. So this is how you make hydrogen compound with a covalent bond. Okay, so now let's learn how to name any covalent compound. So then how you name it, so you always name the first element, the name of the second element. The name of the second element should end with IDE. So this is how you name it, and then you have to insert a prefix indicating the number of each atom type. So mono prefix used for only for the second element. For example, the compound N2O. So how many nitrogen you have in this compound? 2. So the prefix for the first non-metal is di, because it has 2 means di. The name of the nitrogen element, which is nitrogen, dinitrogen. Then you have to write the prefix for the second non-metal, even though it is 1. So for 1 the prefix is mono is 1, mono. Then oxygen is oxide, so name is dinitrogen monoxide. Similarly for NO, what should be the name? How many atoms of nitrogen you have? 1. So if the number of atom for the first non-metal is 1, we usually don't write mono, but for the second non-metal we have to write mono even though it is 1. So remember this. So in this case we are not writing any prefix like mono, we're just writing the name of the non-metal, and then for the second non-metal, even though it is 1, like we had for nitrogen, we still have to write mono. This is a rule. And then oxide, oxygen is oxide, so nitrogen monoxide. Right. What about this one, CO2? So you have carbon, oxygen. So even though carbon is just one atom, we usually don't write mono. Mono is one, so we just write carbon. Then second non-metal, oxygen, how many atoms of oxygen you have? 2, so you have to write di. Di is for 2. And then oxygen is oxide, carbon dioxide. So this is how you name it. But let's see what are the different prefix that we use for different number of atoms on the next slide. So this is a table showing you what are the common prefixes we normally use to write the name of the covalent compound. So now if the number of atom is 1, 2, 3, 4, 5, we usually write mono, di, tri, tetra, penta, hexa. Right. So let's try to name. Make sure you remember what kind of prefix we use for whatever the number of atoms, so that you have to write it. Make sure you remember it, because you're gonna use it to name covalent compound. Now let's try to do some problem on this. Name this compound carbon dioxide. How would I know we have to use a rule for covalent compound or ionic compound? Because carbon is a non-metal, oxygen is a non-metal. So non-metal is a covalent compound. I know we have to use a covalent compound rule. So how many carbon you have in there? 1. So carbon. How many oxygen atom you have? 2. So you have to write di. Di is for 2. Oxide. Oxygen is oxide, dioxide. What about the second one? Again, non-metal, sulfur, fluorine, covalent compound. So sulfur is 1. We usually don't write mono for the first non-metal. So sulfur. How many fluorine you have over here? 6. 6 is your hexa. And then fluorine is fluoride, hexafluoride. If you have I2F7, what should be the name for this I2F7? So the time I see 2, and these are both non-metal covalent compound. So 2 is di. Name of the first non-metal, iodine. Then fluorine is 7. 7 is your hepta. And fluorine is fluoride. Let's do one more. PCl5. Phosphorus is non-metal, chlorine is non-metal, so we just write phosphorus. 5 is penta, chloride. So this is how you know. Even though we have phosphorus 1, we usually don't write mono for the first non-metal. So phosphorus pentachloride. So this is how you name any covalent compound. Now let's try to do another kind of problem on this covalent compound. What is the molecular formula for these compound? If I give you, or if the problem asking you to write the formula, if the name is given, nitrogen trifluoride, nitrogen is N, tri means 3, fluorine is F. So you have 3 fluorine, so you can write NF3, 3 fluorine in there. Sulfur trioxide, as sulfur oxide is oxygen. How many oxygen you have? 3, so SO3. So this is how you name or make a formula if the name is given. Now let's do one more problem, and then in this particular problem you have to figure it out whether the given compound is ionic or covalent and try to name those compound. So the problem is saying name the following compound indicating whether they are ionic or covalent. So the time I see the first one, AlCl3, metal plus non-metal, metal plus non-metal, ionic compound. And how we name it? Al belongs to third group, aluminum chloride. You don't write 3, 4 ditri, right, for ionic compound. Carbon and S sulfur both are non-metal, covalent compound. Carbon disulfide, you have 2 sulfur in it. FeO, iron is a metal, oxygen is a non-metal, metal plus non-metal, ionic compound. And iron, was the charge on iron in this case? +2, because oxygen is -2, so iron 2 oxide. The fourth one is non-metal again, that's why it's a covalent compound, and the name will be 2 nitrogen, dinitrogen, 4 of oxygen, 4 is tetra oxide. So this is how you can identify whether the given compound is a covalent, ionic, and how should we name those compounds. So now we're gonna talk about a new topic called loose dot structure, and then in this topic we're gonna learn about what is loose structure and then what's the purpose of learning the loose structure for covalent compound. So let's go to the next slide and then try to learn about all these things. So whenever we talk about the molecular formula for any compound, we just know what this compound is made up of, which atom normally combine to form this compound. For example, carbon dioxide. I know to make a carbon dioxide we need carbon and oxygen, but what are their structure, what kind of bond this carbon dioxide we have, we cannot know, or we cannot tell by the naming of the molecular formula, right? Similarly, NO2, nitrogen dioxide, we just know this nitrogen dioxide is made up of nitrogen and oxygen, but we don't know anything about what kind of bonds you have and what kind of electrons you have in there to make the structure, right? So molecule formula do not show how atoms are arranged or the type of chemical bond you have. And then for the structure, to study the structure, or we need to study the chemical structure of the chemical, right, to get more understanding how the chemical work, right? For example, chemical structure of hydrogen gas H2 is this: H single bond, one bond H. So how would I know that hydrogen has just one single line or one covalent bond? So we're gonna learn about this thing, and this thing is gonna solve by a special structure called a loose dot structure. We're gonna learn in the next slide. So what is loose dot structure? Loose dot structure normally account for all the valence electron present in the molecule. So how are you gonna get, so loose dot structure, as the name is saying, dot structure. You can make a loose dot structure for any element. For example, if I say carbon, how would I know how to draw the Lewis dot structure? So Lewis is a scientist who showed that only account for the valence electron. So we only know that whatever the chemical reaction that any compound or atoms are doing, they are doing using their valence electron only, right? The last electron present, the last energy level. So if I talk about carbon, how many valence electron carbon has? 4, because it belongs to the 4th group. So there is a special way of drawing a loose structure. So for 4 valence electron, you have to put one single dot for each valence electron. So 1, 2 all across the atom. So each dot represent valence electron, because carbon has 4 valence electron, so that's why I drew 4 dots. If I say sodium is a metal, how many valence electron? It belongs to the 1st group, just 1 valence electron, so put 1 dot only. If I say about magnesium, 2nd group, 2 valence electron, put 2. Nitrogen, how many valence electron? 5, put 1, 2, 3, 4, 5. So you cannot pair the electron unless or until you just put 1 electron each all surrounding the atom, right? And then you can pair them up. For example, fluorine, 7 valence electrons. So 1, 2, 3, 4, 5, 6, 7. So it doesn't matter which way you start counting it. You can go clockwise or counterclockwise, it doesn't matter, as long as you have the electron all surrounding the central atom or that particular element, you can say. Okay, so this is a electron dot structure. The dot represent valence electron, and then it's given by the Lewis, one of the scientists, so that's why the name is given on the name of the scientist, Lewis dot structure. So there are some of the example from the periodic table. The Lewis dot symbol for the atoms. For boron, 3 valence electron, 3 dots. Carbon 4, we already talk about. Oxygen is a 6 valence electron, so you have 6 dots surrounding the oxygen. Phosphorus is 5 surrounding the 5 dots. 5 valence electron, hydrogen has 1 valence electron, so just 1 dot, right? So this is how you can make a loose dot symbol for any element or any atom in the periodic table, depending on how many valence electron that particular element has. So now let's try to understand how many bonds each particular element can make in a covalent compound. So let's talk about the atoms of group 4a element. So if any element belongs to the group 4, how many valence electron that particular element has? 4 valence electron. And to make a fully filled octet, how many electron it need to get shared? It need 4 more electron from somebody else to get shared. So that means any element belongs to the 4th group can make 4 bond. For example, carbon belongs to the 4th group. How many valence electron? 4. 1 2 3 4. And to make 8, how many more electron this carbon need? 4 more. And is there any atom that can share? Let's take an example, hydrogen. Hydrogen has how many valence electron? 1. And how many electron hydrogen need to make it stable? 2. This is an exception, if you remember. So carbon goes to the hydrogen and says, okay, we can share each other. You can give me 1, I can give you 2 in a shading, and we can make a bond. So now you are stable. It need 1 more hydrogen, 1 more bond, 1 more hydrogen, 1 more bond, 1 more hydrogen, 1 more bond. So if you see over here carefully, this carbon has how many electron now? 8 electron. 4 of its valence electron and 4 from each of the hydrogen, because now they are being shared 50-50. Same thing for each hydrogen, 2 electrons, because hydrogen need 2. 1 from is already 1 valence electron, and second coming from the carbon valence electron, because they are sharing 50-50 again 2. So each atom are balanced. Each atom is fully filled, has fully filled octet. So everyone is happy. So this is how you know how many bonds that particular element belongs to that particular group can make, right? So 4th group element can make 4 bond. 1 2 3 4. Similarly, 5th group element can make 3 bonds, because 5th group has 5 valence electron. How many it need more? 3 more. So somebody has to share 3 electrons, so that means 3 bond it can make. 6, 2 bonds. 7th group element can make 1, because they need just 1 electron to get shared. Somebody can share 1 electron, right? Okay. So this is the same example of methane CH4 that we just discussed on the previous slide. Carbon has 4 valence electron, each hydrogen has 1. When they combine together, they make 4 single bond, and then we have a special term called bonding pair of electron. What is bonding pair of electron? Those pair of electron that participate in bond formation. So if you see over here, this is 1 bond, and how many electrons are making 1 single bond? 1 from each side, 2 electrons, right? So if I say about pair, so to make a single bond, 1 line, you need 1 pair of electron. So if I say how many pair of electron you have bonding pair in this CH4, we have 4 bond pair. Why 4 bond pair? This is your 1, this is 2nd pair, this is 3rd pair, this is 4th pair. So you have 4 bond pair. But how many total electron? 8 electron, because each bond pair means 2 electrons. So 8 electrons. Now let's take one more example for NH3. So this is ammonia. Nitrogen belongs to the 5th group. How many bond it can make? 3, because it needs 3 more electron from somebody else which can share with nitrogen to make it 8, because it has 5 valence electron. So nitrogen has 5 valence electron, each hydrogen has 1. So what they're gonna do, this is 5, 1 2 3 4, 5. So hydrogen come close. This is hydrogen electron, this is hydrogen electron, this is hydrogen electron. So they're gonna make one single bond. They pair this one, this bond, and this bond, right? So now let's see how many electron each element has. So let's talk about the hydrogen. How many electron hydrogen need? 2 electrons. So this is already 2. 1, 2. So this hydrogen is good. This hydrogen also has 2, 1 from the nitrogen, 1 from its own, 2, good. This nitrogen, good. What about nitrogen? How many electron nitrogen? And it has to have 8 electron, right? That's what they are sharing. So 1, 2, 3, 4, 5 from the valence, and 1 electron getting shared from each hydrogen. So total of 8 electron across the nitrogen. So this molecule is good. Each atom is happy. But the problem is, can you tell me how many bonding pair of electron you have in this molecule? So that means you have 1, 2, 3. 3 bond pair. Because you have 3 bond and each bond has 1 pair of electron. And then we have a special term. If you see about this pair of electron which is just sitting on the top of nitrogen doing nothing, it's not getting participated to make a bond. So that's why we have a special name for those pair of electron that doesn't get participated to in the formation of bond. We call those pair of electron are non-bonding pair. So how many non-bonding pair you have in here? 1 pair. And then we have a special name too for non-bonding pair as lone pair. So is a synonym. Either you can say non-bonding pair or a lone pair, or you can say bonding pair or a bond pair. So don't get confused if you get a different name, lone pair or non-bonding. So they have the same meaning. So now let's try to do one problem here. Tell me how many bonding and non-bonding electrons you have in water. So this is the structure of water, H2O. How many bonding pair you have? This is 1 bond, this is second bond, single. So you have 2 bond pair of electron. And how many lone pair or non-bonding pair of electron? This is a pair which is not doing anything. This is one more pair of electron doing nothing, sitting on the top of oxygen. So you have 2 non-bonding pair of electrons, or you can say lone pair of electron. 2 lone pair. So lone pair, non-bonding are same thing. So this is how you can determine how many bonding non-bonding electron or lone pair of electron you have. Let's do one more example of hydrogen fluoride. In this structure, how many lone pair, bond pair? So you can see just 1 bonding, so that means 1 bond pair of electron. And how many non-bonding pair? You have 1 pair, second pair, third pair. So that means you have 3 non-bonding pair of electrons or lone pair of electron. Lone pair of electron. Right. So this is how, make sure you know how to calculate lone pair and bond pair for any given molecule in the covalent compound in the loose dot structure. So now we need to know there are 3 kind of bond that covalent compound can make. One of them is called single bond. Single bond is just 1 single line. That means to make a single bond you need 2 electrons from each side, 1 electron from each side, right, to make a single bond. Then you have a double bond and triple bond. Double bond means 2 lines. So how many electron is getting participated? 1, 2, 3, 4. So that means you need 2 electron from each side of the atom to make a double bond. Then you have triple bond, 3 lines. How many electron? 6 electron, 3 from each side. Right, so that means 3 shared pair electron or 6 electron altogether. For double bond, 2 shared electron or 4 electrons together, right? So you can have single, double and triple bond. And then we'll do some example about this. We already done the example with single. Let's do some example with double and triple bond. So this is the example of loose dot structure containing double and triple bond. So if this is the structure, these are the single bond, you have one bond, single bond. This is your double bond, means 4 share electron or 2 pairs of electron, means 4 electron. And then this is your lone pair of electron. And how many lone pair you have? You have 2 of them, 2 lone pair of electron. Then we have an example for a triple bond between nitrogen and nitrogen. If you see, you have 3 lines, that means you have 3 lone pair. How many electrons are being shared? 6 electron, or you can say 3 pairs of electron. And then how many lone pair you have in this nitrogen N2 gas? This is your structure for N2, nitrogen, NN. So you have 2 lone pair electrons. Right. So now this is the table typically tells you about the number of bonding and non-bonding pair of electron for an atom in a molecule. So let's say if we talk about the carbon belongs to 4th group, 4 valence electron. It need to have 4 bonding pairs, so total is 8, because we need 8 electrons across the atom. For nitrogen and phosphorus, if you have 3 bonding pair, means total of 6 electron, and 1 lone pair means 2 electrons, so total is 8 electron. So this is how nitrogen and phosphorus make a bond with any other atom. For oxygen and sulfur, 2 bond pair, 2 lone pair, 4 electron, 8. For halogens, you need just 1 single bond, 1 bond pair and 3 lone pair. So 1 bond pair is 2, 6 electron from 3 lone pair, 8. And for hydrogen, just 1 bond pair. There won't be any lone pair, so total is 2 electron, because hydrogen needs just 2 electrons. So this is how you can calculate how many lone pair, bond pair each atom will have in the structure. So till now we just learned about how to draw the loose dot structure for single atom, right? But how would I know how to draw the loose dot structure for a molecule? So we're gonna learn there are some set rules that you need to follow to make a loose dot structure for any given molecule. So let's start with one of the example and then follow along me and then remember the rule. So we're gonna draw the loose structure for this molecule, carbon tetrachloride CCl4, and then so the first rule says determine the total number of valence electron in the molecule. How would I know how many total number of valence electron we have in CCl4? So you have to add the valence electron for each element separately, calculate and then add them together. So in CCl4 you have 1 carbon has 4 valence electron. Then you have chlorine, each chlorine is 7. How many chlorine you have in there? 4. So 4 plus 28, 32. So in CCl4 I have a total of 32 valence electron. Yeah. So this is how 32, and then we already show you through a loose dot structure for each atom, chlorine 4, 1 carbon. So this is how also you can determine the total number of valence electron. Now the second rule says determine the central atom and place a single bond between the central atom and each atom bonded to it. So to make a compound, make sure you have to figure out the central atom. And how would you know which one is a central atom? So you can apply the rule most metallic element will be at center. And how would you know most metallic? Means those element which is closest to the metal. Even though both of them are non-metal, which one is more closer to the metal side or to the left side? If you remember, we normally get the metal on the left side of the periodic table and non-metal on the right side. So even though all the compound in the covalent compound are non-metal, but you have to see through the periodic table Out of the two non-metal, which one is more toward the left side, means more closer to the metallic side, so that element will be at the center. So if you see CCl4, carbon and chlorine, carbon is more closer to the left side in the periodic table, more towards the metallic side, so that's why carbon is at the center. Or you can say carbon has 4 valence electron, that's why it's also at the center. So the rule says put carbon at the center and then put Cl, 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 Cl all across it. Make sure you know this thing. To make a molecule has to be symmetrical. You cannot put on the carbon, you cannot put all the chlorine on one side, because in nature everything is symmetrical. This is wrong, so this is right. So this is symmetrical, all chlorine is across the carbon. Right? And then how many total valence electron we had before we draw this structure? 32. This is the total number of valence electron, and to make one single line, how many electron we already used? We used 8 electron. So how many left now? 24. So now we have to see how we can put a 24 electron on this molecule. And remember, we cannot use more than 32 or we cannot use less than 32 to make this molecule. We have to use exactly the same total number of valence electron that we calculated. Okay, so now let's go to the other slide. But just remember this, we have just only left with 24 valence electron out of the 32. Now the third rule says that we already done. To calculate how many total number of valence electron we have, how many we already used to make a single bond, we left with 24. Now to use the rest of the valence electron, always start from the outside element first. Don't start from the center to outward, always start from outward to inward. So you have to fulfill the octet of the outside element first. So let's start with this chlorine. This chlorine has 2 electron. How many electron more this chlorine needs? 6 more to make it 8. To put 6 dot 1 2 3 4 5 6. So and then same thing happen over here for the second chlorine. 2 is already in there. How many more it need to make it 8? 6 more. 1 2 3 4 5 6. Same thing apply for this chlorine, same thing apply for this chlorine. So the time I put these dots across the chlorine, how many dots I put? 6 on this, 6 on this, 6 on this, 6 on this, 6 times 4, 24. So that means I used all the 24 electron. Now I don't have anything to work on it. So before you say this is the right structure, make sure you confirm this each element has got 8 electron. If there is anything without an 8 electron fully octet, that structure is not right. So let's start with this carbon. Let's start with the outward one. How many electron is total as 6 plus 2, 8. This chlorine 6, 1, 2. This 6 and then one line that is 2 electron 8. This chlorine 6, this line 8. So each chlorine atom in this molecule is fully filled, 8 electron across it. So each chlorine is happy. Let's talk about the carbon, the center one. If the carbon also has 8 electron across it, that means carbon is also a fully filled octet. So this carbon has 4 single bond, and each bond needs 2 electrons. So that means 4 means 8 electrons. So this carbon is also happy, has 8 electrons. So this is the right Lewis structure for CCl4. So this is how you make a Lewis dot structure for any molecule by using all the 3 rules that we just discussed. Let's do one more problem on the next slide. So now let's try to make a molecule with C2H4. Now we're gonna use this molecule and try to draw a Lewis dot structure for this molecule. What's the first step? Figure it out how many total valence electron you have in there. So carbon has 4 valence electron. How many carbon you have? 2 of them. So total is 2 times 4, 8. Then each hydrogen is 1 valence electron. How many hydrogen atoms you have? 4. 4 times 1, 4. Total is 12 valence electron in this molecule. Then what's the second step? Carbon is more metallic, or carbon has to be the center because carbon can make 4 bonds. So you use carbon, and then you have 4 hydrogen. Don't put all the 4 hydrogen on any one carbon. Make sure by rule the structure has to be symmetrical. In nature everything is symmetrical. So if I put 1 hydrogen in here, 1 hydrogen in here, then I have to put other 2 hydrogen on the other 2 carbon, and then make a 1 bond between carbon. So let's say how many electron I used to make these all single bond. So 1 2 3 4 5, I use 5 single bond. Each single bond is 2, 5 is 10. How many electron left? Only 2 electron left that I can use. If I put let's assume you can put both the electron in any of the carbon. Let's assume if I am putting on this, so we used every electron that we had to make this molecule, but how would I know this structure is right? To make confirm, everything has to have 8 electron except hydrogen. Hydrogen has to have only 2 electron. Let's compare. This hydrogen has 2 electron because it has 1 single bond. This hydrogen is happy, 2 electron because this is single bond. This hydrogen is happy, has 2 electron because hydrogen need only 2 electron. Let's talk about both the carbon. If both the carbon has 8 electron, then this structure is right. Let's talk about the first carbon with a lone pair on the top. So it has 1 2 3 single bonds, 6 electron, and then 2 on the top, 8. So this carbon is good. What about the second carbon? 1 2 3 single bonds, 6 electron, but this carbon is not happy. It doesn't have any 8 electron surrounding it. So what's gonna happen? So this structure is not right. But the carbon next to it says, okay, I have a lone pair which is not doing anything. They are just sitting. So what I can do, I can share the electron with you. So what's gonna happen? So to make a single line, how many electron we need? 2. So it has already 2. So remove this 2 dot from the top and make one more single line, means a double bond. And let's try to remove this 2 bond from the top now. So now this is the right structure. Now you see both the carbon has 8 electron, all the hydrogen have 2 electron. So this structure is right. So this ethene has a double bond between carbon and carbon. So always remember this thing. If the central atom is short of an octet, turn a non-bonding pair or a lone pair bond to make a double or triple bond. That we did in this structure. I use a lone pair or non-bonding pair to make a double bond to fill out the octet for the second carbon. So remember this rule too. So now let's try to make different structure. We have 3 different molecules. You have to draw the loose dot structure for each of them. Let's try to do it together. So let's do with ammonia. So first, what's the first step? Figure it out how many total valence electron for ammonia you have, NH3. So nitrogen has 5 valence electron. Hydrogen has 3 valence electron. Each hydrogen is 1, so you have 3 hydrogen, 3, so total is 8 valence electron. So you have to use 8 electron to fill out this NH3 molecule. So nitrogen has to go at the center, put hydrogen surrounding it in a symmetrical manner, and put 1 single bond. So the time I put single bond, out of the 8 I use 6, and then how many left? Only 2. So can I put 2 dot on each of the hydrogen in any of the hydrogen? No, hydrogen is already happy. They already have 2 electron. What about nitrogen? There is nothing else. We have to put the rest of the 2 electron on nitrogen. So let's say if every atom is happy, hydrogen are happy because they have 2 electron. What about the nitrogen? Nitrogen has 3 bonds. 3 bonds means 6 electron and 2 electron on the top, 8 electron. So this is your right structure for ammonia, NH3. And how many bond pair you have in there? I can say in ammonia I have 3 bond pair and 1 lone pair or non-bonding pair. Let's do S2S. H2S. How many total valence electron in H2S? Hydrogen has 1, total of 2. Sulfur has 6, so total is 8 valence electron. I have to use 8. So put sulfur at the center, put hydrogen across it, put 1 single bond. So out of the 8, if I use 2 single bond, I use 4. I left with only 4 more electrons. Should I put electron on the hydrogen? No, hydrogen is happy. Both of them has 2 electrons. Then there is no other choice to put 4 electron on sulfur. Now let's see if every atom is happy or not. Hydrogen is happy because they already have 2 electron. What about the sulfur? Sulfur has 2 single bond, 4 electron and 2 lone pair, 2 on the top, 2 on the bottom, so 8 electrons. Sulfur is also happy, so everything is happy in this H2S. So this is the right structure for H2S. What about chlorine? Cl2. How many total valence electron in chlorine? Each chlorine has 7 valence electron. You have 2 of them, so 7 times 2, 14. And let's put chlorine, Cl, Cl. Put 1 bond, 1 single bond to attach them. So out of the 14, if I put 1 single bond, how many electron I use? 2 electron. So out of the 14, I use 2. So that means 12 are left. We have 12 more electron to put across this molecule. How many electrons the first chlorine need to fully fill? 8 electron. We need 6 more. 1, 2, 3, 4, 5, 6. Same for other chlorine. 1, 2, 3, 4, 5, 6. And then the time I put 12 dot, I use all the 14 electron. 12 dot means 12 electron and 1 single bond means 2 electrons, so 14. Everything is gone. Let's compare if every chlorine is good, has 8 electron. So 6 electron on the top, on the side doing nothing, and 1 bond means 8 electron. This chlorine is good. What about the other chlorine? 2, 4, 5, 6, 7, 8. This chlorine is also has 8 electron. So this chlorine is also good. So this is the right loose structure for Cl2 molecule. So this is the same example that we did. We have all the example in the solve form too, so you can read it one more time. But we already discussed about all the 3 structure on the previous slide. We already drew it everything using a loose dot structure. So these are the example that you can see. This is for part B, H2S. We already done with this with the rules. And then the last one is Cl2. And then we already got this structure with 6 electron on each chlorine, pair of 6 electron and 1 single bond. So let's take a couple of more example molecule to make a loose dot structure for that molecule. We'll go with carbon dioxide. So what's the first step? Total number of valence electron. How many total number of valence electron we have in carbon dioxide? Carbon has a valence electron of 4. And then each oxygen has 6. How many oxygen we have? 2. So 6 times 2, 12. So total is 4 plus 12, 16. So that means I have a total of 16 valence electron. Now the second step is between carbon and oxygen. Which one is more metallic? Carbon. So put carbon at the center. Molecule has to be symmetrical, so I am going to put each oxygen on each side of the carbon. Put 1 single bond so that they get connected. So the time I put single bond, how many electron I use? 4 out of the 16. 4 is gone. We left with 12. So now let's try to fill it out, the 12 electron. We always start from outside to inside, right? We have to fill it out the octet for the outermost atom first. So how many dot we have to put on this oxygen? 6 to make it 8. And again on this another oxygen is we have to put 6 because oxygen needs 6 to 8. 6, 1 single bond, 8. Other oxygen 6, 1 single bond, 8. So we are done with everything. Now we don't have any more electron to put it on the structure. So now let's verify each atom is happy, have 8 electron. Yes, this oxygen is happy, it has 8 electron. This oxygen is happy, has 8 electron. But what about this carbon? How many electron this carbon has? This carbon has just 1 single bond, means 4 electron, so it's not the happy one, so it need 4 more electron, and then we don't have any more electron left, so how are we gonna make it? So this oxygen say I can share the electron, both the electron, and this oxygen also say, oh, I'm also have several electron that is not shared, I can also share with you. So the other structure is gonna be, now you have a double bond carbon, then double bond carbon, and then 4 electron on oxygen. Now each atom I have 8 electron. So in carbon dioxide we have a double bond, not a single bond, right? And each single bond comes from the each oxygen atom because they are rich in free electron. Let's do an example for nitrogen N2. Let's say how many electron we have in nitrogen. Each nitrogen has 5 valence electron, so 5 times 2, total of 10 electron. Let's put it like nitrogen, put one single bond. Out of the 10 I use 1, now we left with 8. So 1 2 3 4 5 6 7 8. Right. So now each nitrogen has 6 electron, right? So this nitrogen say, okay, I can share the electron with you. So the time it's shared, it become nitrogen double bond, then this nitrogen, the other one, second one has 8 electron, but this nitrogen that shared the electron has now 6. So the other nitrogen is gonna share it one more electron pair, so you're gonna get triple bond. Now each nitrogen in this has 8 electrons, so nitrogen always make a triple bond or a 3 bond to make a fully full octet. So nitrogen gas has a loose dot structure of N triple bond. So how many lone pair you have in there? We have 2 lone pair and 3 bond pair. For carbon dioxide, how many lone pair I have? I have 1 lone pair, 2 lone pair, 3 4. I have 4 non-bonding pair or a lone pair, and then how many bond pair? 2 bond pair here, 2 bond pair here, so 4 bond pair. Bond pair, lone pair, LP. So this is how you normally make a loose structure for different molecule and figure it out how many lone pair and how many bond pair they have in the structure. So I think that will be it for this particular chapter, which is ionic and covalent compound, and I'll see you on the next chapter. Bye.